Hi everyone. So let's discuss about the difference between the list data type available in a built-in Python functionality and a NumPy array which is available in a NumPy library. So we have already seen how to create this NumPy array, and those all NumPy array we have created with the help of this list data type only. But what is the basic fundamental difference between list and a NumPy array, and why this numerical Python community has created this NumPy array? What is the performance benefit we are getting for this NumPy array over the list data type? So let me first create one list. So let's say A. I just want to put the elements like, let's say 1, 4, 4.5. Let's say this is a string. I'm going to keep it here, and let's say one boolean. Yeah. Okay, so we have created a list. Now if you observe in this particular list, there is a non-homogeneous kind of element we have kept it here. Like a couple of elements are like integer, and then we have a floats, then string, boolean. So it's like a mixture of non-homogeneous element. Now let's say I will try to create the NumPy array with the help of same list. So same array function we are going to use from this NumPy library, and I will just supply A. Now if you see, while creation of this NumPy array from this list data type A variable, all the elements of this particular list got converted into kind of string. So true also becomes string, string was already a string, 4.5 was a earlier case, it was a float, but now it's a string. 4 is also become string, and 1 is also become string. So now it indicates that NumPy accepts the homogeneous kind of element, and that is the one important thing about this NumPy array, because if you don't keep this homogeneous element in a NumPy array, so in that case you cannot take advantage of all those kinds of matrix related operation, linear algebra related operation, what you can perform very fast with the help of different functionalities are available in a NumPy library. Whereas in case of this list, all the elements which are not homogeneous in a nature, so you just cannot predict that what kind of operation will be same applied on every single element available in a list. So that is a one basic fundamental difference. Let's see another one. So I have pasted it here. Yeah, let me make it marked down. Okay, so the first one is like a NumPy is fixed in a size. So that means that it cannot grow, but it can grow actually. But what it is trying to say that it can create a complete new array, whereas list can grow dynamically. So what it tries to indicate is that once you create this NumPy array, it will occupy some space in a memory, and when you try to do any kind of modification related operation on the top of this NumPy array, it will completely destroy that original one and create the new NumPy array in some different locations in a memory. Whereas in case of list, it will keep creating and keep appending, keep deleting element, so it can grow like a dynamically. Okay, so from end user perspective, it doesn't make any sense, because in both the data type you can append element, you can delete element, and all those kinds of modification operation you can perform. But from the memory perspective, this NumPy will completely destroy the original array and create the new array. The another one is like a list. List has a like a overhead to store all the memory location. So let's consider this particular list. So we have total 5 elements are available. To represent or to store all those 5 elements in a memory, those 5 elements has to be associated with 5 different location, and all those 5 different location this list data type has to take care, and every single memory location is pointing to one element of this list data type. So it is like a overhead to store every single memory location, whereas in case of NumPy array, it is expecting that only similar kind of data type we are going to store. So in a contiguous memory location, it will store every single element available in a NumPy array. So in that case, what happens that when you want to fetch some particular element out of this NumPy array, let's say 4.5, so if you know the base address, because as the every single element available in this NumPy array got stored in a contiguous memory location, if you know the base address, based on the base address, let's say everything is less like a float, so every single element occupy 4 bytes of space in a memory. So it is a 4 byte, another 4 byte and 4 byte. So from the base address you can go to the 12th location and you can immediately grab that particular element. And in this case the NumPy array do not need to store all those memory location also. You just need to store that original base address memory location from where in a memory this NumPy array started. So that's why the performance wise also NumPy array is very much fast, because it do not need to iterate over every single memory location array and then from memory location array to you go to the actual value array. But in case of NumPy array you just take care about all those values because everything just stored in a contiguous memory location. Now performance wise, let's do some small experiment. So let's create a 2 array. So 2 list which is having, let's say 10,000 value, and with the help of basic constructs available in a Python, we will try to measure that to do any kind of operation on those 2 lists, how much amount of time it will take in case of list and how much amount of time it will take in case of NumPy array. So we'll get the idea that how fast that NumPy array from the performance perspective. Okay, so let me create one variable like let's say size. So let's say size, I'm just going to take it 100. Okay, or let's make it 1000. First let me create a 2 array. So let's say I'm going to create, let's say x1 or range. I'm going to use the range size, and another variable I'm going to create like y1. So 2 list has been created whose values are 0 to 999. If you just display it, you can see this one. You can iterate over this one. Now we are going to use one magic functions available in this Jupyter notebook, so which is nothing but the time it. So time it will tell that on an average, if you execute all the code written in this particular cell, how much amount of execution time it will take. So let's use list comprehension to multiply element by element multiplication of each individual element available in this x1 and a y1 list type. So let's say x1 I am going to multiply with y1 I for in a range, let's say size, and let me just execute it. So we have got the results. So based on some statistic calculation with mean and standard deviation of 7 runs, so might be 7 times it has tried to execute this particular statement, and the result we got like a 397 microsecond for running this particular statement on an average, I would say. Okay, so to do the element by element matrix, or I would say element by element multiplication of 2 array which is having a size 1000, it took 397 microsecond plus or minus 13.2. On an average it was taken 397 microsecond. Now let's do the same operation on a NumPy array and let's see how much amount of time it is going to take. So size we are going to fix it like 1000. Let me create another 2 array like let's say x2, let's say a range and size, another one like a y2. So now we have not a range object but we have a NumPy object, and let me use the same time it function and let's just multiply x2 by y2. So it's going to do the element by element multiplication of x2 and a y2. Okay, let's just execute it. Now you can see the difference that compared to 397 microsecond in case of this NumPy array, it has just taken 1.67 microseconds. So it's close to around I would say 200 times at least faster this NumPy array is. So let's do experiment with 10,000 even. Okay, let me create a x1 y1 again and let's just execute with the help of this built-in list comprehension, and let's see how much amount of time it is going to take. So it has taken 4.06 millisecond. let's do with same on a NumPy array. So x2 y2 has been generated. Now let's go for x2 multiplied by y2. Okay, so now you can imagine that how much fast it is. It has taken 4.06 milliseconds, which is roughly around 4000 microsecond, whereas in case of this NumPy array it has just taken 10 microsecond. So it is almost 400 times faster this NumPy array is. So my idea behind this particular video is to show you what is the difference between this list and a NumPy array, and how you can take advantage of this NumPy array, because as at a ground level language, this all NumPy array has been written in a very base language like a C language it has been written. So that's why performance wise it's too much faster. Okay, so that is all about fundamental differences between list and a NumPy. You can even do experiment with even different higher number of size like 1 lakh or 1 million, and you can see about the performance, that how fast that NumPy array is. Okay, so that is all about this video. See you into next video.